In this lesson, we will learn about basic cryptography. First, we have encryption. Encryption is used to provide confidentiality and not let an unauthorized person see or access the protected information. And that's by changing or encrypting the original data in plain text, the readable form, to a ciphertext that cannot be understood unless it was decrypted in some way. So for example, if we have this word welcome, if we encrypt it, we get it in a ciphertext that cannot be understood unless it was decrypted back to the original form. We have two types of encryption. The first type is symmetric encryption. Symmetric encryption uses one secret key for both encryption and decryption. It's also known as a pre-shared key because it has to be shared previously for the encryption to work. So for example, here we have user A and user B. User A is trying to send this document to user B, and to encrypt this document with symmetric encryption, user A will generate a secret key, then make another copy of the secret key. The second copy of the secret key will be sent to user B. Now that user A and user B both have their own copies of the pre-shared key, user A will encrypt the document with its copy of the pre-shared key and send it to user B. Then user B will use its own copy of the pre-shared key to decrypt the document and get it back in plain text. But the downside to symmetric encryption is the need to transmit or send the keys used for encryption and decryption. If someone gets their hands on the pre-shared key while it was being sent to user B, then the third party that got their hands on the pre-shared key will be able to also decrypt the data just like user B. So because we can't ensure that the key was not intercepted, this method of encryption is less secure. On the other hand, with asymmetric encryption, which is the second type of encryption, we use two key pairs. One is a private key that is kept in private and not given to anyone, and the other is a public key that is given to the public. Whatever was encrypted with one key cannot be decrypted with anything other than the second key. So here again we have user A and user B. This time user B is trying to send a document to user A. User A has its own private key and public key. User B also have its own private key and public key. To start encrypting, first user B needs to get the public key of user A and encrypt the document with the public key of user A. Now this encrypted document cannot be decrypted with anything other than user A's private key, which was not given to anyone and was kept safe by user A. So user B will send this document back to user A, and user A will decrypt the document to plain text with the private key it got. It also works the same way if user A was trying to send a document to user B. It will first get user B's public key, encrypt the data with it, and send it to user B, and user B will decrypt it with its own private key. So these two ways of encryption, the symmetric encryption and asymmetric encryption, have their own advantages and disadvantages. Symmetric encryption have the advantage of being faster than asymmetric encryption, and it also have no ciphertext expansion, meaning that the generated ciphertext is not bigger than the original plain text data. And the disadvantage is being less secure because of the secret key that must be shared in the beginning. With asymmetric encryption, the disadvantage is being slower than symmetric encryption and have ciphertext expansion. So the generated ciphertext is larger than the original plain text data. This makes it not a good option when transmitting bulk or big chunks of data. To fix this problem, or to just have the best of both encryption mechanisms, you can use both of them together. So first generate a pre-shared key, then use asymmetric key pairs to encrypt the pre-shared key and securely send it to the other party. Then the rest of the communication will be using the pre-shared key or symmetric encryption. This way, we are using the advantages of both encryption methods. Next, we have hash or hashing function. Hash is a function that will generate a unique digital fingerprint of data. It's primarily used for comparison purposes and not for encryption, like when you want to know if two pieces of data are identical, so you create a hash of both, and if the hash match, then these data pieces are identical. There are three characteristics of a hash. First, they are non-reversible or one-way function, which makes it different from encryption. Because with encryption, you can encrypt, then decrypt the data to get it back to its plain text form. But with hash, you can't reverse. You can't take the hash result and try to get the original plain text data. Second, it has a fixed size. Big or small amounts of data will give you the same hash size. You can hash a whole book or one word, and they will give you a hash result with the same size, depending on what hashing algorithm you're using. Hashes are also unique, so different data cannot produce same hash. You can hash a whole sentence, then change one letter and try to hash it again, and both hash results will be different from each other. So for example here, if we take this hello world and if we try to hash it with MD5 hash, we will get this hash result. It's a one-way hash and cannot be reversed to get the original hello world in plain text. This hashing function is used in digital certificates, and digital certificates are basically equivalent to handwritten signatures. They provide electronic verification of the sender, so some type of authentication where the receiver will have a reason to believe that the message they received was in fact sent by the claimed sender. It also provides integrity to make sure data was not modified. So let's say user A wanted to send a document to user B, but before sending the document, user A will create a hash of the document and encrypt the hash with his own private key. Then send the document and the encrypted hash to user B. This encrypted hash is the digital signature. When user B receives the document and the encrypted hash, first, it will try to decrypt the hash with the user's public key. If it works, then this document must have been really sent by user A, because user A is the only one that have his own private key. Next, user B will try to check the integrity of the received document. So it will hash the document and compare the hash result with the hash received from user A. If it's the same, then the document was not modified. And lastly, we have digital certificates. Digital certificate is used to create confirmation of who is on the other side of communication, because anybody can generate a symmetric key and pass the digital signature. Digital signature will only check if the other party have the other pair of the key I'm using. It doesn't check if that party is the one I'm trying to really communicate with. But with digital certificates, we have a trusted third party called a certificate authority, or CA. Those CAs are reliable and will verify the owner of the public keys. Digital certificates bind or tie an owner with their public key. They allow us to verify whom a public key really belongs to. Both parties will first register and prove their identities to a known certificate authority. Then, the certificate authority will prove their identity with a digital certificate that includes a lot of information, like the certificate holder, a serial number, expiration date of the certificate, and most importantly, a copy of the certificate holder's public key. This way, we have the public key and a certificate that verifies the owner of this public key.